Alright guys, let's review how to add and subtract unlike fractions. Just as a reminder, unlike means that the two fractions have completely different denominators. So if I were adding a fraction like 1/2 and 1/2, these are like fractions because they both have a denominator of 2. Or maybe I wanted to add 5/7 and 1/7. Those are also like fractions because they have the same denominator. So we are just trying to figure out what we do when we have unlike fractions because the unlike fractions are not very easily added. So like when I had 5/7 plus 1/7, the answer to that question would be 6/7. But when I have unlike fractions, it's not as simple to add. So let's take 1/2 and 1/3. If I have to add these fractions, I cannot simply combine them the way that I do when the fractions are like. So what I have to do is I have to use my knowledge of equivalent fractions and create two new ones. So the way we do that is we take a look at these two denominators and we try to come up with what we've been calling the least common denominator, or LCD, least common denominator. And the least common denominator is simply the least common multiple between the two, which is something we talked about in 4th grade. So multiples, we know, get bigger as we multiply by each counting number. So for example, the multiples of 2 would be 2, 4, 6, 8, 10, and so on. The multiples of 3 would be 3, 6, 9, and we can actually stop here because I already notice that they both have 6, and the least common multiple is the first multiple that both numbers share. So since the least common multiple of 2 and 3 is 6, that means that the least common denominator of these two fractions is 6. So the least common denominator is very, very similar to the least common multiple. It's just that when I use this language, I'm talking about numbers on their own, for example, 2 and 3. And when I use this language, I'm referring to fractions. So now that we know that the least common denominator is 6, we can create two equivalent fractions to add these successfully. So let me rewrite these, 1/2 and 1/3. I know my least common denominator is 6. So that means that my new denominator is 6, and I have to remember how to get there. Well, how to get from 2 to 6? I use a magic number of 3, and remember that whatever we do to the bottom, we also must do to the top. 2 times 3 is 6, and 1 times 3 is 3, so my equivalent fraction is 3/6. That makes sense because my original fraction was 1/2, and I know that 3 is half of 6, so certainly 3/6 is also 1/2. Let's do the same thing over here. My new denominator is 6. How did I get there? Well, with the magic number of 2. 3 times 2. Do the same up top. 1 times 2, my new fraction is 2/6. These are much easier to add because now I have like fractions. So 3/6 plus 2/6 is 5/6, and that is the answer to our question. Let's take a look at another example. Let's say I have 2/3 and 1/12. All right, so again, I'm looking at these two fractions. They are unlike. I need new denominators so that I have like fractions to easily add. I notice that between 3 and 12, the least common denominator of these two fractions will be 12. I can actually keep 12 because I know that 12 is the first multiple of 12 and 12 is the fourth multiple of 3. So then I ask myself, how did I get there? How did we get to 12 from 3? I use the magic number of 4. Since 3 times 4 is 12. I have to do the same thing up in my numerator. My new fraction is 8/12. Over here, I already have a fraction with a denominator of 12, so I just simply keep it the same. Now I can add these easily, and I see that my answer is 9/12. Now this should be striking us as a red flag at this point in 5th grade, because I can see that 9/12 is not in simplest form. As a matter of fact, both of these numbers can be divided by 3. And so I'm going to reduce this fraction to its simplest form. 9 divided by 3 is 3. 12 divided by 3 is 4, and so my final answer is 3/4. So let's take a look at a couple examples where we're needing to subtract unlike fractions. Let's say I want to subtract 2/7 from 4/5. All right, so I'm actually going to go through the same process that I did when I was adding my unlike fractions. I again have to come up with a least common denominator. And let's see, between 5 and 7, I'd say the least common multiple is 35. And again, if you aren't able to see that right away, then what you can do is on the side, you can list your multiples of 5. And then list some multiples of 7. And then you can see that 35 is the first time that they match. I also want to remind you that we did learn a ladder method in 4th grade to find the least common multiple. And like I said, the least common multiple is pretty much the same thing as the least common denominator. It's just that I'm referring to fractions. If you remember, when we were in 4th grade, we learned that we can find the least common multiple of two numbers if we make this ladder and we try to see if we can divide up the number any smaller than we already have. 5 and 7 can't be divided any farther than they already are, so they end up being the same. And so remember that to get the least common multiple, we simply multiply all of these numbers that are at the bottom of the letter. So 1 times 5 times 7 is 35, which tells me 35 is the least common multiple. Let me show you an example where it's not so straightforward like that. Let's say I was trying to find the least common multiple of 6 and 8, for example. 6 and 8 can both be divided by 2. I then get 3 and 4. 3 and 4 cannot be divided any farther, so I'm done. And 2 times 1 is 2, of course, times 3 is 6, times 4 is 24. So the least common multiple of 6 and 8 would be 24. So if my fractions both had a denominator of 6 and 8, then I would need to change to the least common denominator of 24. And that's just a quick way to do it. Or you can just list out the multiples like we did before. Either way that works for you. All right, so let's get back to this. So I'm changing to a fraction out of 35ths. How did I get there? Well, I'd have to multiply times 7 to get 35. So I have to do the same thing in my numerator. So my new fraction is 28/35. And then over here, 7 times 5 will get me to 35 in my new fraction. So I have to do the same in my numerator again, of course. And so my new numerator is 10. These are my new equivalent fractions. They're now like fractions, and I can easily subtract. 28 minus 10 is 18/35. This fraction is in simplest form, and so I am done. Let's take a look at another example that came up when we were in class that was a little bit strange, a situation like this. What if we have something like a whole number and we're taking a fractional piece away? Well, before we take a look at this, I'd just like to remind you that a whole number can be written as a fraction. So the thing is that we're dealing with thirds. So I'm asking myself, I need to find a way to write two wholes in thirds. So I know that one whole is 3/3. And so certainly two wholes would be 6/3. So this one's a little bit different. I'm not needing to find a least common denominator. Instead, I simply need to write my whole number as a fraction, and I know that 2 wholes is 6/3. Then I'll take away my 1/3, and now I can see that the answer is 5/3. Just like before when we were talking about simplest form, this fraction that I've just written should be a red flag to you. 5/3 is not a proper fraction. It is improper because the numerator is bigger than the denominator. So I actually need to change this using the division rule. The way that we do this is we know that the numerator is always the dividend Every fraction is really a division problem. So 5/3 really means 5 divided by 3. So what I'm doing is I'm writing that up here with the division symbol so that I can go to work and figure this out. So 5 divided by 3. 3 can go into 5 one time with a remainder of 2. 2 what? 2/3. So 5/3 is actually 1 2/3. And that makes sense because I know again that there are 3/3 in one whole. So 3 of the thirds are right here, and here are the other 2/3, and 3 plus 2 is 5, and I used to have 5/3. And so we are done. Thank you for watching, and good luck.